Hello. Hello and welcome to this video on a review of functions and operators of PostgreSQL. In the last video, we went through string functions and we studied till format. Now we will look at format function details as well as bind string functions and operators. So without further ado, let's get started. The function format produces output formatted according to a formal string in a style similar to the C function sprintf. So like C sprintf, it takes one mandatory argument, that is the format str, and other arguments are optional. One could be format arg any, and then there could be any number of arguments. Format str is the format string that specifies how the result should be formatted. Text in the format string is copied directly to the result except where format specifiers are used. Format specifiers act as placeholders in the string, defining how subsequent functional arguments should be formatted and inserted into the result. Each format argument is converted to text according to the usual output rules for its data type, and then formatted and inserted into the result string according to the format specifiers. Format specifiers are introduced by a percentage character and have the form percentage position flag width type. Where the component fields are, position is optional. All three position flags and width are optional. A string of the form $n where n is the index of the arguments to print. Index 1 means the first argument after format str. If the position is omitted, the default is to use the next argument in sequence. Flags. Additional options controlling how the format specifiers output is formatted. Currently, the only supported flag is a minus sign, which will cause the format specifier output to be left justified. This has no effect unless the width field is also specified. Width specifies the minimum number of characters to display the format to display the format specifiers output. The output is padded on the left or right depending on the minus flag, with spaces as needed to fill the width. A too small width does not cause manipulation of the output but is simply ignored. The width may be specified using any one of the following: a positive integer and messages to use the next function argument as the width, or a string of the form star and dollar to use the nth function argument as the width. If the width comes from a function argument, that argument is consumed before the argument that is used for the format specifier value. If the width argument is negative, the result is left aligned, as if the minus flag had been specified within a field of length absolute width. The type of format conversion to use to produce the format specifiers output, the following types are supported. S formats the argument value as simple string, a null value is treated as an empty string. I treats the argument value as an SQL identifier. Double quoting it if necessary, it is an error for the value to be null. L quotes the argument value as an SQL literal. A null value is displayed as the string's null without quotes. In addition to the format specifier described above, the special sequence percentage may be used to output a literal percentage character. Here are some examples of the basic format conversions. So we have hello percentages and world as arguments. The percentages will be replaced by world. Then we have testing and we have 1, 2, 3 strings which will be replaced by 1, 2, 3. And percentage will be replaced by percentage. Then we have insert into percentage I values percentage L. So this is an identifier, so it will be double quoted. And values is single quoted. Okay, because as you see, I is an SQL identifier and L is SQL literal. Okay, so it will be taken as SQL literal. Then we have insert into percentage I values percentage L. So identifier will be locations and value will be program files. Then we have percentage 10 as foo. So this will be right justified and 10 will be the width. So 7 will be spaces and then foo. And then minus 10 and we have 7 spaces for foo. And similarly, you can study all the remaining formats. So this is star. So if we look at the description of star and asterisk to use uh, the next function argument as the width. So here next function argument is 10. So width will be 10 and foo will be right justified here. And minus 10 means left justified. Similarly, minus means left justified and star s means this 10 as the next argument for the width. And similarly for this. So here are two minus signs, you see, and still it is justified. So negation and negation does not mean it becomes positive. Then we have position fields. So percentage $3 means third argument, percentage $2 means second argument, and percentage $1 means first argument. Similarly, here if you see this percentage, this star means a width of 10 here, and $2 means bar, so it will be like that. And here if you see it's complicated a bit, $1 means foo, star means width, and then $2 is the second argument. Okay, so the result is foo because there is no space left for bar. Unlike the standard C functions as printf, PostgreSQL's format function allows format specifier with and without position fields to be mixed in the same format string. A format specifier without a position field always uses the next argument after the last argument consumed. In addition, the format function does not require all function argument to be used in the format string. For example, select format testing %3, %2, %1, 1, 2, 3. So here, if you see this, %3 would be 3, %2 would be 2, and %s would be the next argument, that is 3 again. The %I and %L format specifier are particularly useful for safely constructing dynamic SQL statements. So you can look at example 41.1 and you can see how you can put values in dynamic queries. Okay, so there is quite a bit of information here. So we will go back and now we will study binary string functions and operators. So let's see how much we can cover. You should be able to finish this. So for example, if you want to run this, then on PostgreSQL, you simply take it and paste it on the prompt, and we will have the output. Binary string functions and operators. This section describes functions and operators for examining and manipulating binary strings, that is, values of type byte A. Many of these are equivalent in purpose and syntax to the text string functions described in the previous section. SQL defines some string functions that use keywords rather than commas to separate arguments. Details are in table 9.11, that is this table. PostgreSQL also provides versions of these functions that use the regular function in notation syntax. So first we have concatenation operator, as you know. So you can take a binary string and concatenate it. Then we have bit length, and it returns how many bits are consumed by the binary string. For example, 1, 2, 3, 4, 5, 6, it is 1 byte, 8 bits. So, and 6 hexadecimal number means 24 bits. Then we have btrim, just like btrim we have studied in string functions and operator. So it takes a byte a argument or byte array, and it removes this value from the beginning and end. So here 90 will match at the end and 12 will match at the beginning. So we will have 3, 4, 5, 6, 7, 8. Then we have LTrim, which will remove the string or trim the string from the left end. So for example, I can show you one such example. So select, there we go. So if it would be B trim, it would trim from both ends. Similarly, we have octet length, which is bit length by 8. So this is number of bytes in the binary string. We have overlay, just like we had for string, byte array, byte array, placing new substring byte key from start integer. So here bytes will be of the type byte array, the new string will be of type byte array, start will be an integer, and optionally for count, which will be an integer again. So it replaces the substring of bytes that starts with the started byte and extends for count bytes with new substring. If count is omitted, it defaults to the length of new substring. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. And we are placing 0, 0, 2 and 0, 0, 3 for 2, from 2 to 3. So 2 is this, and we have to place up to 3. From, let's see if it says from 2 to 3. So it will definitely start here. 2, placing 0, 0, 2, 0, 0, 3. So if we place 0, 0, 2 and 0, 0, 3. So these two zeros become 1, 0, I believe. I'm not sure. So unless this 0, 0, 2 becomes 0, 2, it won't work. Okay. I'm not sure. I will need more information. It does not talk about from start integer. Let's go back a bit. It says replaces the substring of bytes that start at the started byte from start integer. So start integer, started byte to count bytes. So this is the second byte, and for count byte. So up to 3 bytes. 3, 4, 5, 6, 7, 8. And it will replace them. Okay. From 2 second byte to for 3 bytes. It will start placing at second byte and it will replace till for 3 bytes. So it will become 0, 2, 0, 3. So 3 bytes are replaced by 2 bytes, 0, 2 and 0, 3. So certainly this 0, 0, 2 becomes 0, 2 and 0, 0, 3 becomes 0, 3. So that's of the meaning. It took me a bit of time to understand this. Position has one argument, substring, which is of type byte array, and in bytes. Returns first starting index of the specified substring within bytes, or 0 if it is not present. So position of 5, 6, 7, 8, if you see, it starts at third byte. 1, 2 is first byte, 3, 4 is second byte, so it will give you 3. Then we have rtrim, just like ltrim, removes the substring matching pattern from the right side. Then we have substring, just like the string function, it is analogous to that. So it extracts the substring of bytes, starting at the started byte if that is specified, and stopping after count bytes if that is specified, provide at least one of start and count. So from third, so we will leave for 2 bytes, and from third for 2 bytes. So 5, 6, 7, 8. Then we have trim, leading, trailing both, just like string, and it behaves like that. And then we have trim, which is non-string, the syntax for trim. Additional binary string manipulation functions are available and are listed in table 9.12, that is this table. Some of them are used internally to implement the SQL standard string function listed in table 9.11, that is the previous table which we studied. First is bit count, which counts the number of bits in the binary string, also known as pop count. So let's see how many set bits are here. Okay, number of bits set. So 1 will have 1 bit, 2 will have 1, 3 will have 2, so 4. 4 will have 1, so 5. 5 will have 2, so 7. And 6 will have 2, so 9. 7 will have 3, so 12. 8 will have 1, 13. And 9 will have 2, so 15. So 15 set bits are here. Then we have CRC32, which computes the checksum of a binary string, CRC checksum 32. Then we have CRC32C checksum for a byte array or binary string. Then we have get underscore bit, which gets the nth bit from the binary string. So you have two arguments. One is the binary string, another is the position of that bit. Then we have get byte, which extracts nth byte from the binary string. And we have length, returns number of bytes in the binary string. Then we have length again, which also optionally takes the encoding name of the binary string. Like CRC, we can compute MD5. MD5 was also there in string. We have reverse. Reverse is the order of bytes in the binary string. Set bit sets nth bit in the binary string to new value. So it takes three arguments, binary string, the position, and the new value. Then we have set byte, which sets nth byte in the binary string to new value. So like set bit, it will take position as well as the byte value, and it will replace that byte. We can compute SHA-224 hash, SHA-256, SHA-384, and SHA-512 hashes of binary strings by invoking these functions. So ideally, you should use SHA-256 onwards, because SHA-224 is SHA-2 is also broken. You would probably want to use SHA-384 or SHA-112 actually. Then we have sub-str, which takes a binary string, start integer and count integer. What it does is it extracts the size substring of bytes starting at starteth byte and extending for count bytes if that is specified. If the count bytes is not specified, we go to the end. So we have this binary string and we start at third byte. So 5, 6, 7, 8 because count is given as 2, so 2 bytes. Function get byte and set byte number the first byte of binary string as byte 0. Functions get bit and set bit number bits from the right within each byte. For example, bit 0 is the least significant bit of the first byte, and bit 15 is the most significant bit of the second byte. For historical reasons, the function MD5 returns a hex encoded value of type text, whereas the SHA-2 functions return type byte array. Use the functions encode and decode to convert between the two. For example, encode SHA-256 ABC, hex to get a hex coded encoded text representation, or decode MD5 ABC, hex to get a byte array value. Functions for converting strings between different character sets, that is encodings, and for representing arbitrary binary data in textual form are shown in the table 9.13. So I think we can cover this, but let's do this in the next video. So in the next video, we'll start with table 9.13. So I hope that you are enjoying this read through, and there is not much to exemplify because the functions are quite simple and the examples are given. So for example, if you want this, you can simply paste it here and it will give you the SHA 512 values. So database values functions are quite fast because Postgres is written in C internally, and therefore it runs at a very high speed. If you are doing SHA-512 computation in something like Python, it will be much slower, particularly if the string is large. So with this, I will end this video, and we will meet again tomorrow to continue where we have left. That is, we will start with this table where we will study text and binary string conversion functions. And possibly after that, we will go and study bit string functions and operators. Let's see how much is there. We should be able to cover these. Pattern matching, I will reserve separately. So tomorrow we will cover till here. That is till 9.6, we will finish this. So tomorrow will be relatively small video. So, excuse me. I thank you for watching the video, and don't just rely on the video. You can go ahead and read the documentation itself. Or if you find that boring, then please wait and I will come up with that video and we can learn together. So once again, thanks a lot for watching the video. Enjoy.